$1,000, give $1,000. Whatever it is, the Lord's leading you to do. And the Lord will speak to your heart. And what we have here is an older style quantum energy device. This particular style was developed approximately 20 years ago by our ministry. And you'll see it working. Should I go through all the parts?
Yeah, go ahead and explain all the parts.
Okay. Basically, we'll start over here at one end, and this is a variable transformer to control the speed on the motor, the drive motor. And this is the standard drive motor. It's not been altered. It draws 7.4 amp volts. That's what it's rated. And so it gives you an idea. You can do the computation, see what the horsepower just on the motor, what it requires that motor to run properly.
And what's the little...
This is a diode bridge.
Okay.
And over here we have a variable transformer, diode bridge, motor, a belt that turns the pulleys that goes to the rotor of the main generator. We can see it turning, and you can even see through the window. You see the rotor turning in there.
Yep.
And you have the two main output coils, not the output coils, they're the main vibrating coils, we call it that. And here's the capacitor bank here on the side. It's been shrunk down from the old capacitor bank. The old one we had was very, very durable, but it was very big, and people thought maybe there's batteries hidden in it or something. So we try to make this presentable where everybody can understand it, even the people that don't have much background in quantum engineering. And so a few of our volunteers did a beautiful job giving us a nice little capacitor bank here. And here's some of the electronics. There's more electronics in this blue box back here. And that's where the switch is on top of that blue box, but there's other stuff inside of it. And also there's electronics in this blue box. And again, the switch is on top of the blue box. And then here's the load. And the load is a bunch of light bulbs that you'll get to see lit up. And the cord basically is set up where we start it with regular power with this yellow cord here, and then we can unplug it once it's working and quickly turn it back to run itself, and then light up the bulbs one at a time. This particular device, you have to take it up slowly and take it down slowly because of the way it's built. But they can be built to produce power immediately, large surges and so on. We originally had this one putting out 40 kW at one time. But today we'll demonstrate it at about 2 kW or 2.1, 2.2, somewhere in that range.
Okay, well let's go ahead and start it up.
Today we'll demonstrate it at about 2 kW or 2.1, 2.2, somewhere in that range.
Okay, well let's go ahead and start it up.
Okay. Starting it up, we'll plug it in. We make sure everything looks right. There's nothing loose, nothing messed up, as near as I can perceive. Everything looks like it's supposed to be. And turn it. By the sound where it's right and where it isn't. Now let's make sure we got power. We do have power. So the first thing we'll do is run the load, or the motor, because that's the largest load on the system. So the first thing we'll do is unplug it and switch it over to from the power output back to this motor.
Okay.
Right there's a little trick, but sometimes it doesn't work right.
Okay, so basically it is running itself now.
Yeah, let me make sure it's running a little faster, I think. I don't know if you can tell that or not. So the power must be a little bit different. We keep it pretty close. That's supposed to be exactly, when I looked at it on the scope, it was exactly the same as what's coming out of the wall as far as 60 cycles and the right voltage. What happens is the power input changes depending on the time of the day. The power comes from the power company. It changes in voltage. It actually goes up and down. Some days it'll be 115, other days it'll be 124 around here. So that's why it's a little different just now. Anyway, you don't need that. Let's light up some lights, unless you have any other questions.
Nope, I think that's good.
And I don't know if you zoomed in or not, but those are all 100 watts. You can read it on a lot of them. Give people an idea how much power it is.
Okay, I didn't hear any slowdown of the motor.
I heard a slight one on the third bulb or the fourth, fifth bulb. You can play it back. At least it sounded like it to me. It wasn't a slowdown. It was actually a mellowing out, a little smoother. It sounded a little smoother. You can play back the video and listen to it again. But, I heard a slight one. Maybe over that.
Okay, I'm going to basically just pan across the machine here.
And your question there about slowing down, that is old school science. Quantum energy does not require additional loads of any kind. Quantum energy is the energy source unto itself. If you build it right, you don't have to have the machine slow it down.
It looks like you've got, what is that, 14 light bulbs burning.
Yeah, we didn't turn on one, I guess. Okay, now it burned out there for a second.
Okay, now you got 15 light bulbs.
So 1,500 watts there.
1,500 watts.
And then you got the 70 amps, 7.4 amps over here, and 90 volts roughly. So you can do the math, but it's probably around 2,100 watts or 2,200 watts, somewhere in there, 22,000 watts, somewhere in that range. And originally, I don't know if you want to show the transformer, but originally we ran a transformer just like this, and we burned out the transformer. We had it loaded to 40 kW. So we don't do it that high in this system anymore. But we've actually burned out several of these types of devices. The main challenge is handling the power when you get the bigger devices. But this is all totally doable. It's all been worked out. 130 years ago it was worked out by Nathan Stubblefield. He's part of our ministry. Tesla, other people worked it out, and this is not lost, it's not secret. A lot of it's in the public domain. All of Tesla's patents are in the public domain. Tesla's patents have to do with this. We've taken it further. They didn't have electronics in those days. They didn't have electronics in those days, so we've taken it a little further than Tesla had it. And so we've got other patents besides that. But the patents are not the main thing. The main thing is getting this to the people. The main thing is that the people can benefit. And so that's why we're focusing in on the factory. We're focusing in on getting these things mass produced.
So what we've got here is a self-running generator. It's basically providing over 2,000 watts. This will run indefinitely without fuel.
Like anything, it runs until the parts wear out. When you say indefinitely, yeah, that's true. It is indefinitely, but indefinitely means basically until the parts wear out.
For instance, moving parts would wear out.
Parts and solid state parts wear out. Televisions go bad, computers go bad. They're all solid state. They still go bad. There's still parts that wear out. Cell phones go bad. Different things.
Okay, so really the really special part of this technology is the rotating generator in this machine, and you might talk just a little bit about why that's special and what makes it that your ministry has been able to make such a small generator put out this amount of power.
Why it's special?
Yeah, why it's special and what the technology is that's
A
actually...
little bit about the technology. Okay, basically there's many types of subatomic particles, and it's the way you make those particles and the way you establish them as to whether or not you get over unity. There's over 100 types of subatomic particles defined now, and everybody used to think that the only thing that flowed through wires was electrons. Well, that's not true. Nowadays, quantum physics realizes there's many types of subatomic particles, and depending on what those particles are, which ones you have, in which places, and which vibrations you have, in other words, frequencies in which places, and what the power levels are, and how they're arranged with each other, and where the standing fields are. That all has to do with how it works. If you get it right, well, basically by different combinations of those things, you can do anything you can imagine, including space travel and everything else, teleportation and all that. But basically, one of the simplest ones was making energy, and that's what we're focusing in on here.
Okay, and with this device, that's a standard variable transformer that you adjust the speed of the motor with.
Yeah, that's a standard motor too.
Standard motor, standard belt drive, and a standard load of regular incandescent light bulbs. So the real technology is in the generator and how it's built and how it works. All right. Well, I guess where would people find out about this?
Well, we have a website, WITTSministries.ws.
That's right. Or there's a shorter version, just wits.ws.
Okay, there you go. WI with two T's or WI? Okay. WITTS.ws.
Predictions. AI is playing a great role in medicine, manufacturing, education, and mobility. From self-driving cars to smart devices, AI is everywhere. AI also finds its application in building robots and chatbots. Some of the top companies working on AI are Google, Microsoft, Tesla, IBM, and Facebook. Some of the skills you need to possess to become an expert in artificial intelligence are Python programming, mathematics, machine learning, and deep learning. As per Markets and Market, the global artificial intelligence market will grow from $58.3 billion in 2021 to $309.6 billion by 2026 at a CAGR of 39.7%. With so much advancement in the field of artificial intelligence and companies spending billions of dollars, there's absolutely no doubt that AI is the future. But the question arises whether AI is the greatest technology that humanity has ever seen. Well, only the future will tell us. With that being said, if you are interested in learning to create something interesting and help make a difference. Hi there, if you like this video, subscribe to the Simply Learn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.